says this is the applicant has to be from a European country.
Also applies to
Taiwan. Or has to go to a European country. Also,
But Taiwan has become a European country.
yeah. Maybe not the best time, but I mean, actually, when I do this talk,
morning, ladies and gentlemen. We are about to begin our conference today. So please find yourself a comfortable seat. Jordan, Professor, and distinguished speakers and our guests. I'm very honored to welcome everybody to come to the 2013 conference on the ELSI of biopharmaceutical research. On behalf of the ELSI group of NRPB and the National Taiwan University Bioethics Center, and also the Department of Social Medicine, College of Medicine, NTU. We are very honored to organize and prepare this small conference. And we have a distinguished professor from France and also our local, our domestic ELSI scholars. We plan to join and to share our research ideas in ethics law and social impact on research ethics issues. And in this conference, Professor Jordan will give his keynote, and then later our participant research we will present their research papers from different perspectives. In the past 2 years, the ELSI group of NRPB has been devoted to improving better ethic and legal regulatory framework for biopharma research. And at the same time, equally or even more important is promoting the public consultation, deliberation, and also communication and education. So for that purpose, the public engagement group has been devoted to communicating with the general public and also the focus patient groups through different type of workshops or focus group meeting. And we know that in past few years, there has been quite a lot of advancement in our medical research, as well as the IRB regulation and legal framework and legal legislation increased a lot for better self-protecting human subject research in Taiwan. And there have been lots of interesting debates and also some dilemmas generated in this context. So today we have different topics focusing on research ethics and law, and also some research paper concerning the public consultation process and the general public's their opinion toward medical research. So we expect to have a very fruitful exchange through today's conference. So on behalf of the organizing bodies, I express our utmost welcome to you all. And so we are moving on to our first speakers. And I'm very honored to introduce Professor Xie Fengzhou, formerly Professor Dai Hua. He will be chairing this the next section. His good friend, Professor Jordan. But Professor Dai Hua, because he has had some urgent issues, urgent meeting in Chengda, so he won't be able to be here. And at the last minute, my mentor, Professor Xie Fengzhou, actually saved me, so he is willing to chair these sessions for us. Let me do a little introduction to Professor Xie Fengzhou. Xie Fengzhou, he is actually the co-founder, founder of our NTU Bioethics Center. And he also founded many important research centers in NTU. He has been very famous for his innovative ideas and stimulating comments, encouraging our young generation to do something different. So every time I met him, I was quite often kind of 被他骂. kind of accused or criticized by his critical points. But we know that his encouraging and challenging opinions quite often help us move forward to the next era. So let's welcome Professor Chen to chair this session.
I'm the 这个叫做救援投手。Okay, but today I'm very happy that just last week Dr. Cai Buchang get promoted to full professor. Okay, so let's give him a big hand. And he told me he'll prepare a big banquet for us for celebration. Okay, I think for him it's a very important landmark. In the medical campus, usually what is important is the cure of physical disease. Okay, so for because Buchang is deal with something very abstract like ethics or integrity or law, actually it's not important, actually, I know about the words of integrity until I am 60 years old. Before that, I don't know these words. Okay, so I think, his promotion becomes, I think there will be very, significant impact because he is now, has a good position to speak up for the right things. So I encourage him, and maybe also our coming university president, Professor Yang. I think I told him that the next stage, the important things in Taiwan might not be nature or science paper, but the social justice. So he think I'm crazy, but I think that's what I heard. So I think I just surprised to see the topic. So today is involve the prenatal diagnosis. I think it's a messy issue now. Okay, actually it is the major field of my past maybe 20 years, but we start nothing, start from scratch the so-called maternal serum screening in Taiwan in about 1990. Okay, and 2 years has passed. Recently I saw the statistics that is every year we have about 180 Down syndrome baby were detected prenatally. And of course, most of them were terminated. And the living Down syndrome every year now, maybe less than 10 in Taiwan. Okay. So what we do is, first we promote amniocentesis. Okay, and then followed by 2-marker Down syndrome screening, and of course we become a 4-marker Down syndrome screening. Okay. I think that's enough to achieve this, 90% detection. But now, of course, there is a new, commercial product like free DNA, okay, or CDH, microarray, something, but it becomes a very, commercial campaign. Okay, so it becomes a very, of course, some stuff. Previous in our hospital. That's actually my students. I handpicked him to help to establish good DNA diagnostic facility for all the Taiwan. But unfortunately, it turned out to be a commercial scandal. And of course, I formally, accused him to the hospital authority. But unfortunately, there is no investigation at all. Okay, so I think this medical campus actually is, very shamed. because I think he has good connections through political connections and economic connections with different level of leaders in this campus. So even if I officially with a written document to accuse him of his misconduct, there is no investigation at all. Okay, so I think I'm very disappointed about. So I think I always encourage Fu Chang that ethics is not just oral service. You have to reinforce it. Okay, so that's why now that he is a professor, now he can speak without any too much consideration. But I think the student learns, they saw instead of they saw what really happens. Okay, instead of they learn, they listen what you talk. Okay, so I think because this prenatal diagnosis involves a very huge commercial interest. Okay, so I think I'm very glad that Professor Jordan will be talking about this, and I hope that maybe we can further elaborate this issue to even to the public setting, okay, through some different academic occasions or academic society to let the society has some correct understanding of this what will be happening with those so-called advancing. So I think perfect child is not possible. Even you can do all kinds of gene testing, because what's serious? What concern the parents most is something like a CP, right? And something like autism, something like learning difficulty, dyslexia, and hyperactivity. I think that cannot be tested through those DNA diagnoses. So what can as far as I know, even with the amniocentesis plus RACTH, the detection rate of abnormality maybe increase just a little bit. Okay, so for me, I think but actually it really changed things, because before we use DNA. Chromosome examination, we promote ultrasound screening for the so-called 20 weeks gestation. Actually, only with that we have eliminated very very big spectrum of all congenital defects. Things like the congenital disease accounts for about 1% of congenital defects, but the difficult thing is severe things like single chamber. I think it can be easily found by ultrasound before birth, so it was eliminated. Okay, so we had just only ASD, VSD for the pediatricians to work up. Okay, so it actually changed the whole picture of the pediatric disease spectrum. So I think so everyone was very curious about what the DNA can do in the future. It's ready for the future parents, and of course there are lots of commercial promotions. Okay, so there's all kinds of connections between physicians and merchants. So I think today, Professor Jordan, the topics is just in time to give us some very, I think will be very productive insight into this issue. Thank you.
Thank you very much. Well, let's get this on. Okay, very good. So I'm not an ethicist. I'm a molecular biologist or a genomics person. So I'm not going to give conclusions, well, not many conclusions on what should be done. Well, what I thought I wanted to do is to alert you to what is going on, because there's really a very fast technical progress due in particular to new generation sequencing, to the fact that it has become very easy and very inexpensive to sequence human DNA. And this is getting into clinical practice, and this is having impact in many fields. Of course, it's having a lot of positive impacts, but it's also raising a number of problems. And so I thought it would be interesting with this audience to tell you about the latest developments in the general field of prenatal diagnosis. So let's see if I can operate this. Yes. So new generation sequencing, you know, this is a kind of technical revolution that began about 5 or 6 years ago. After the genome program was finished, the genome program was done with sort of conventional technology which had been invented around 1977. But starting in 2005, 2006, new systems began to appear, and okay, they are based on a lot of progress in electronics, optics, micromachining, and so on. And they essentially sequence millions of DNA molecules simultaneously. So they provide enormous amounts of data at relatively little expense. Initially, those were big machines. I mean, machines which typically cost $500,000 and which are able, in one session, to sequence to a good quality level a whole human genome, something which had previously taken 10 years, billions of US dollars, and thousands of scientists. So this is a site which gives you a world map of where these machines are located. I know this doesn't work, of course. Well, you see a lot in the US, of course. You see a big cluster in China, that's in Shenzhen, that's BGI. If we zoom in on Taiwan, actually there's quite a few of those systems in Taiwan, mostly in Taipei and around Taipei, of course. Okay, this is quite striking. This is the evolution of the cost to sequence one human genome over the years. Okay, the first sequence of the human genome, you can say it cost maybe $1 billion US. But by 2001, if you wanted to sequence another human genome, the cost was about $100 million US. The solid line is the decrease of the cost of computing. This is so-called Moore's law, where the cost of computing goes down by a factor of 2 every 18 months, which is very, very fast. I mean, it doesn't look so fast on this image just because of the scale, but just think about it. If Moore's law applied to cars, our cars would cost 50 cents and would run at the speed of light. So this Moore's law shows a very quick decline, and as you see, the decline of the cost to sequence one human genome more or less follows Moore's law until 2006, 2007. That's where the new machines began to be fairly widespread, and you see then it drops down quite dramatically. So, of course, depends how you estimate how good the sequence must be and so on, but this is the cost for a reasonably good human genome sequence with estimated less than one error every 100,000 bases. And this is now down to maybe $5,000 or $6,000, and it's probably continuing to go down. There is yet another generation of machines around the corner, and it will probably reach the goal of $1,000 genome quite soon. Of course, that's just getting the sequence, then you have to analyze it, and that turns out, depending on how deeply you want to analyze it, that ends up costing more than $1,000. But anyway, so this means really in just maybe 10 years, the cost of sequencing has dropped incredibly. I mean, 1,000-fold. I mean, it's really quite incredible progress. So as you saw from the number of machines, there are centers doing this all over the world, either in big centers or in research labs, or now also in clinical labs. And so it is indeed beginning to have a strong impact in the clinic. It's used quite widely now for cancer therapy to find out which treatment is likely to be effective in a given patient by actually sequencing all or part of the DNA of a biopsy, of a tumor biopsy, to find out what's the problem in a child which has some problem which you cannot find a cause for. To follow emerging diseases, you may have noticed that now every time a new disease appears, we get the sequence of the agent almost overnight. But and this is my topic for today, so it also allows new approaches in the field of prenatal diagnosis and what you can call embryo choice. So that's what I want to show you. Okay, this is just one of many many papers, well, essentially that say that, this is what I wanted to underline, getting a whole genome sequence in medical care will be as commonplace as getting an annual physical exam, except that the sequence, you only need to have it once, and then you can mine it repeatedly as knowledge improves. So, first thing is prenatal diagnosis. So what is going on in prenatal diagnosis? The important thing which is going on is so-called non-invasive diagnostics. Now, of course, as you know, prenatal diagnosis is normally done by amniocentesis or chorionic villus sampling. These are invasive procedures, they are unpleasant, and they have a risk of provoking miscarriage, which is around 1%. Now, it turns out that if you take maternal, if you just take a blood sample from the mother during pregnancy, the plasma contains some DNA from the fetus. Not fetal cells, you're not looking for fetal cells, you're looking just for free DNA in the plasma. So in the plasma there is a small amount of DNA from the fetus. Of course there's also DNA from the mother, because you always have white blood cells that have lyse and have released some DNA. So it's a mixture. It's a mixture where the fetal DNA is usually around 10% of the total. But actually, if you just sequence without separation, without trying to separate, if you just sequence this DNA and analyze it by bioinformatics, you can actually isolate the contribution from the fetus. So you can actually already now do some kinds of prenatal diagnosis just on a blood sample from the mother, which of course is a lot more comfortable and a lot safer. And so this is done for trisomy testing for chromosome 21 and a couple of other chromosomes. And it's actually already commercially available, at least in the US, and quite successful. So the company which first introduced this kind of test is called Sequenom. There are 4 other companies in the US, and there are companies elsewhere. Actually, I believe BGI is also proposing this type of test. And so at this time, this is mostly done as a screening test for high-risk pregnancies. High risk meaning the mother is over 35 or has some history of problems. So it's quite a large population. And if the test by this method indicates trisomy, then you go for the invasive tests. But that means you avoid a lot of invasive tests. I think I have a price list. No. So this is actually probably the medical test that has been the most successful, the most quickly, because it has, of course, the great advantage that you avoid invasive procedure, and actually, so people who would not have done an invasive prenatal test are quite ready to do this test. Okay, there's some technical issues, but the latest results are really very good. Almost 100% sensitivity and almost 100% specificity. I think the latest that I saw by one of these companies on like 300 women, there was no false positive and no false negative in this whole sample. So it's getting really good. So it's already covered by insurance in the US, which is a big issue in that country, as you know. It may actually turn out to be extended to a general screening, which means 4 million births in the US, 750,000 high-risk pregnancies, but 4 million pregnancies. Okay, of course, there's a lot of legal action between the companies because each one is accusing the other of infringing on its patents. So the professional body, like the American College of Medical Genetics, is a little cautious on the quality control and whether this should be used as a preliminary screening or actually a test. But I mean, this is, I guess, a technical issue that will progress quite quickly as the methods improve. So this is a recent item in Nature Medicine, which shows the 4 companies doing this in the US. So they all look at actually 3 trisomies. They use slightly different methods. At the time of this paper, they had these figures for sensitivity and specificity, but those have got better now. Also, one of the strong points of this test is that it can be done quite early. And you know, in the US, it's getting more and more difficult to obtain pregnancy termination if you want. And so being able to do the test as early as possible is an asset. And you see the cost goes from less than $1,000 to almost $3,000. I need to get some water. I just need to open it. I got it. Okay, so yeah, that's actually a summary of the previous slide. So as I said, this is a very, very successful test, and I guess on the whole it's a progress. There's not, I don't think it really raises very difficult ethical issues, as long as it's properly done, of course, and as long as it's available to the people who need it. Now this can be extended. I mean, if you are actually sequencing this mixture of maternal and fetal DNA, if you're willing to sequence deeply enough, I mean, to have sufficient accuracy and can do more analysis, you can actually go a lot beyond just looking at trisomies, at whole chromosome trisomies. You can look at partial duplications, and you can imagine that it will be possible to actually